Welcome back. In this video, we will be showing you steps 4 and 5 of the textual analysis process. Step 4 will be to tokenize our data, and step 5 will be to clean our data so that it is ready for analysis. Tokenizing our data essentially means we are dividing our data into specified units. Currently, the novel Frankenstein that we have is divided into lines. To tokenize our data, we are going to want to change it so that each word of the novel has its own line. To start this process, we are going to use the unnest_tokens function. If you want to learn more about how this function works, you can type $unnest_tokens into your console to get help with this function. The first thing we are going to do is create a new variable named Frankenstein tidy, and we are going to assign it our new Frankenstein that we made, and then using our pipe operator, we are going to say what we want to do to our Frankenstein new in order to make it tidy. We are going to unnest our tokens, and in there we are going to say we want to unnest by word, and what we want to unnest is the text column. So this line of code is saying take Frankenstein new, unnest the tokens by word, and do that in the text column, and then make that our Frankenstein tidy variable. Let's run this line of code and see what happens. Here is our Frankenstein tidy. We can now see that each word has its own line, as opposed to here, where there are groups of words in each line. The unnest tokens function does a couple things. First, it divides the text into individual words. It also removes punctuation and spaces, and it converts everything to lowercase. If you take a look at unnest tokens with the help function, you will see that a lot of these options can be modified. Feel free to explore this and mess around with how this function works. From here on out, when we have a data frame that looks like this, we will refer to it as a bag of words. This bag of words is much easier to work with than our original novel when it is separated into lines rather than single words. There are other things we can do with this bag of words now that we have it separated. For example, we can use the arrange function to look at things alphabetically. So let's view this, and let's look at our Frankenstein tidy and arrange it by word. You will see that it starts with numericals, and after that, our words go alphabetically. A appears a lot, so we'd have to scroll down a ways to see other words. Another very useful function we can use is the count function, which can count up the number of times each word occurs. Let's try viewing this again. And let's count them. So we will use the count function. We will count by word. And then what we want to do is say sort equals true in all caps. What this is saying is we want to count each word, and sort equals true is saying count the number of times that word appears. This line of code gives us an n value for each word. So we can see here that the appears over 4,000 times, and our words will appear in descending order of occurrences. So here at the bottom, we have words that occur only once. Now that our data has been tokenized, we can clean this up some more. There are a lot of words in a novel like a, and, the, and words like this that have no real value in terms of the meaning or analysis of a text. So we can remove these words before starting our analysis to get a more accurate picture of what the novel looks like in terms of words that have valuable meaning. These words, like a, and the, are called stop words. If you recall from the last video, we loaded a data frame full of these stop words. Let's take a look at it. Here we can see a list of words on the left and their lexicon on the right. There are a few different kinds of lexicons. We have smart words. Scrolling down a ways, we have words under the snowball lexicon. And scrolling even farther, we have some under an onyx lexicon. For most of our analysis in this course, we will be removing these smart words. As you go further along in your analysis and coding process, you might have to modify your smart words list. But for now, we will keep it as is in our stop words data. In the last video, we loaded the Tidyverse library, and this library will come in handy now when we want to clean up our data a little bit more. The Tidyverse library contains something called the anti-join function, which we will be using to remove some of our stop words. Anti-join functions by comparing the stop words data list to our Frankenstein data list and removing words that are in Frankenstein that are also in the stop words. So when it is finished, we will be left with Frankenstein minus any of the stop words we want to remove. Let's start this process. We are going to create a Frankenstein data with our stop words removed. So for shorthand, I'm going to call it frank_sr for stop words removed. Then I'm going to add my assignment operator. We are going to say we want to take data from our Frankenstein tidy variable. Pipe operator saying and then our anti-join function. Here we want to anti-join all of the stop words. Let's see what happens when we run this code. Here is our stop words removed data. Let's compare it to our Frankenstein tidy data. We can see here, this says, to Mrs. Seville, England, you will rejoice too. Here, we can see that to has been removed, you has been removed, and will has been removed. So now it says Seville, England, rejoice here disaster. These words would usually have much more meaning in the text than words like to, you, will, and things like that. So now we have a data object with words that we would actually want to analyze. Keep in mind that sometimes the stop words list contains words we would actually want to keep, and sometimes what one person might consider an irrelevant word would actually turn out to be a very interesting word to someone else. Later on in this course, we will talk about how to customize this stop words list or use other stop words lexica. In the next video, we will start our analysis on this newly cleaned bag of words.